Thank you. Can you hear me, everyone? Okay. Despite that quite fancy title, this is an inspiring report, so I'm going to talk about our experience so far with Scala at its ecosystem. Uh, I'm Jefferson. I'm software developer from Colombia, South America, and currently I'm teaching functional programming in our local university. And I work in this amazing company called 74M, where I have been doing Scala for the last 3 years. So I'm going to start giving you some context. 5 years ago in my country, most of the engineers had mostly Java experience. They had been building monolithic applications. Back then, this approach was enough to tackle the business complexity down. But our economy is starting to become an emerging market, and business processes went more complex. And they need to create value, business value faster as well. This is going to mean that traditional approaches stop to being appropriate for the business new needs. So we started to look in new approaches for address these new concerns in the business that we handle. So, and I was searching for tackle this increasing complexity. We found out that functional programming removes an important part of the complexity, which is the need for account for the previous executions that settle as a program to a certain state. This is just, as you know, functions only take parameters and give you a result. That's it. Also, we found that we can parameterize all the things that we're working on. This implies that all these things will pass through a type checker that could help us to catch a lot of errors sooner. By adding immutability, we can to realize that can also remove the complexity that comes from for dealing with mutable state. But we find that some parts of functional programming have developed certain parents and terminology that could add more complexity than they solve. For instance, we have these horrible names. Who is familiar with these kind of things? No one? This is okay. Because we find that these parents and other parts of FP might require a lot of learning to get into. We wanted to keep the things as simple as possible. So I'm not worried about that names. So in our process, we found that in this point when object-oriented means functional. So we come to realize that functional programming is obviously not just learn a new language. And in this paradigm is still foreign to many engineers. So we decided to start translating the previous knowledge that we have from object-oriented programming to, to functional programming. We found that most practices or principles from object-oriented can be translated to surprisingly functions. Yeah. And for example, to translate single responsibility principle, you can use a function because functions only must have only purpose. Also, you can extend a function's behavior using composition, and so on for the rest of these principles that we are using. In this point, especially using Scala was extremely useful in order to achieve a kind of smooth and incremental transition between these paradigms. Of course, start this transition using these paradigms, we force us to face some challenge. Because we need to keep delivering business value through high-quality software products during this learning process. Also, we have the need to do onboarding new team members and a reasonable time frame, and introduce these new approaches for them in a certain way that made the teams easier for the whole team. But we have the lack of respect on epic topics, and also we have to start doing just a better Java. Uh, Here, meaning better Java for us was not using null values, no true exception, and no use mutable state. At the beginning, this practice is good enough to start the adaptation process, but it's not enough to take advantage of certain parts of functional programming and Scala detail. Like you, through the Scala type system, you can increase the correctness guarantees and improve the code reliability and the testability. And finally, we had to find a way to distribute and unify the knowledge that had been occurring. So our process to face this challenge and merge certain cultural requirements that we have is as follows. We want to have fine-grained control over all the architectural decisions and design implementations. Also, we have the code that takes as the documentation itself. And we can to put that in easy to evolve artifact where everyone in the team can contribute to. It's in this scenario we went to realize that our framework will be enough to face this challenge. So we started building our built-in framework for our code and our challenge. So this is when our reference architecture is born. A reference architecture is just a set of documents and a which an interested party can refer to for better practices, common standards, and patterns. In this context, document means code. And we want that this architecture could show how to combine the different approaches and practices that we have been doing with good results in the past, and also add the new ones from functional programming. For example, we started breaking a complex domains using the DDD's strategic parents, mapping out with these parents also the relationships between these domains. Then we have a natural correlation between a service and a bounded context DDD lingo that will help us to clarify when to use, in which part of the program use secure arrays, without adding significant complexity. And think we have the chance to separate the load that comes from the reads and the writes, and also allows to scale each one independently. Then we focus on the domain nouns. We can abstract the simple types of the domain to create more complex types. And here we find another practice that is model our domains using ADTs. So also we found that using Scala, we have certain features that could help us to express the domain's operation in a spreadsheet typeset way. In this way, we was enabled to using DLCs with finite taglets. We will see this part in a moment. And then we combine all these things that I mentioned before with these architectural styles, because we feel that these architectural styles fits very good with DDD design. So also we are used to have a portable, no technology-dependent business domain and logic. So we can separate the responsibilities and decouple the components of the program. This is because the external ledgers will be agnostic to the inner ones. So in this project, all the developers could know how a service should look like and how to use common partners. Now I'm going to show you the architectural view of this service. Yeah. In the green ledger, we have the domain model. Here you find the domain types. Or in the lingo, here is the place to put the entities, aggregates, and valued objects. In the red layer, there are the domain services, or the set of functions that operates on that domain. Finally, in the blue layer, we will find all the required machinery to receive the events from the outside world. We can transform them to messages that the service can understand and use. Now I'm going to talk about the functional design. So I'm going to omit details about the security layer, viability, latency, and consistent concerns. So yeah. Here I have some notes about boilerplate code. You will see a lot of boilerplate code. But this is, we think that boilerplate code is necessary during the learning process, since things like annotation and other tools to avoid it can hide important implementation details of concepts. So in this phase of the development process, we think that boilerplate code is not that bad. We start to feel, we think removing it when it start to feel boring and repetitive. Is the font size okay for everyone? This is how the base project for a microservice looks like. Here we have a basic, a lightweight version of this architecture. It's just about and how a service to manage that subscription of a user. The subscription can have one of these states. We can model this in this zoom type. Also, we are here using this type parameter bounded to that state. And this gives us the possibility to control the life cycle of the user aggregate and also make illegal states in the domain unrepresentable. Also, we are materializing all our ADTs using this smart construction idiom rather than just create asserts or requires or throw exceptions all the way to the external layers. Here is, for that reason is what we have these errors. We have type errors that has that makes sense in this domain. This is changed to use exceptions and throw all the way up through the ledges of this architecture. Now I'm going to show you the algebra of this domain. Here is the domain services. This is a CRUDIS DLC. with the basic operations to create a user and get a subscription back according to the state that we have. Of course, as I mentioned before, here we are using tagless final to separate concerns. Here we can separate this description. We have here we have the intention to show how user can be stored, but we don't care now in how this method could be executed, or what effect we have in this type constructor. Now I'm going to show you a program. A program here plays the role as a command in secure areas, because the responsibility of this program is orchestrate the domain algebras and handle with the consequence that we had for these executions. Notice that here we are missing the user repository algebra with event algebra. This is a simple algebra to send the domain is events to in this case, to Kafka, the stream platform. Here we are orchestrating the domain services. We are using monad transformers to stacking the possible effects of this type constructor, leave the pure values into this effect as well. Here we can see the event algebra is only to send the domain event to Kafka in this case. Here we are using a bounded context monad, but I want to clarify that not always is needed to use a monad. Here maybe you want to use an applicative and use less power. In certain applications, you don't need all the monad power. Now I'm going to show you the repository that we have. This repository is our interpreter to the domain's algebra. Here we are using slightly arrows to make dependencies injection. And also we can defer the execution of this interpreter to the to the main program when we actually pass these contents to the interpreter. This user context is just a tray with all the needed dependencies. Here we have a production connection and a Kafka producer connection. So here we are missing the algebras to being going to interpret and give it the domain process, the domain workflow is expressed here. Also, this repository is a monadic context itself, which means you can sequence into different interpreters with different over the same program. For instance, we can make this interpreter to a storage, and we combine it by, for say, a login context or another interpreter for doing telemetry over the service. Finally, here we have a gRPC adapter, which is actually when the program will be interpreted. Here I'm using this interpreter that interprets to tasks. Task has the effect to be a lazy and asynchronous computations. And the only thing we need to have here in this point is to interpret the program over the desired effect of tasks in this case. Notice that here we have the impurities that we need to communicate with the external world. We can also express in terms of the domain the happy and the unhappy parts of the business workflow. And this is the most external ledger, and all the things that we deferred before, meaning the executions and the decisions about what types or about what effects we want to use is made here. So in the main program, you only need to declare all the dependencies that you need and pass it to the services alongside with the interpreter of that. Now I'm going to show you how to make tests on that program. You only need to declare a test contents. In this case, we have an in-memory storage and an interpreter on the ID monad. ID monad has the effect of not having effects at all. So it's basically do nothing here. So we take that interpreter on their ID, and we pass it the program with certain points. And that is the basic idea of how to make a test here. I'm going to back to the presentation. I have this final thought. We come to realize that to handle complexity is not a simple task. So we need to keep searching for better ways to doing that. Also, we raise up with abstractions has an intrinsic complexity cost that we also have to handle. And this is the only way to achieve that, to tackle down that complexity. All the decisions that we made here about this reference architecture were focused on people because we have to give them a way to make their labor easier and hopefully happier. So here we have measures of success. We achieved to reduce the mean time to add new behaviors, to fix errors, and to create tests. And actually, I'd like to say that our engineers are happy with this approach. So, thank you. It's not just about to use gRPC instead of, for say, HTTP. We only have to show, want to show that in this architecture, you can add easily more adapters and ports. So you can have a Kafka port, a gRPC port, a HTTP port, whatever you want. It's only for demonstration purpose. That's it? Okay.